today's webinar on getting to know Google Cloud Platform. Mark is a 20-year veteran of the industry. He's a certified Google Cloud instructor. And in addition to instructing on Google Cloud, he's currently working with several startups building applications on Google Cloud Platform. So certainly has the experience in teaching the technology, but as well working with it. So for the next hour, we'll all get to benefit from Mark's experience. So Mark, I'll turn the word over to you. Tell us what we need to know about Google Cloud Platform.
Thank you, Carl, and welcome everyone. I thought to start off, we could ask a poll question just to get a sense of what everybody attending's plans are for Google Cloud Platform. So maybe start off with the poll question. What are all your plans for using Google Cloud Platform in your enterprise?
Good. Okay. Yes. Thanks for introducing that, Mark. So, folks, you can see the poll question there and the 4 possible responses. So just click the radio button as to your plans to use Google Cloud Platform. So excellent. Good. We got about 80% of folks already responded. Any remaining ones, please, now's the time. Chime in with your plans to use Google Cloud Platform. I'll just give you another few seconds there if you haven't yet responded. Okay. Well, thank you, everybody. We've had about 85% been able to respond. Thank you for that. It seems, Mark, that the majority are still unsure of their plans. They're just interested in learning more about Google Cloud Platform. 74% responded that way. 12% said that their organization currently does use Google Cloud Platform. 9% say that their organization is planning to use it. And 5% of the respondents said they are going to use Google Cloud Platform on their own terms outside of work. So thank you for that. Helps us get the event off to a good start. So I'll pass it back to you, Mark.
Thanks, everyone. All right, so in the webinar today, we'll start with an introduction to some of the key features of the Google Cloud Platform. We'll continue on talking about some sample usage scenarios, and then we'll finish with a quick little demo of a popular usage scenario that is deploying a REST API to show how easy it is to deploy REST APIs using the Google Cloud Platform App Engine feature. So with that in mind, let's move along and start with an introduction. So first of all, in the past, you probably are all familiar that co-location was the first stage towards the evolution of the cloud. It gave users the financial efficiency of renting physical space instead of investing in data center real estate. That continued on with the development of virtualization and virtualized data centers, allowing private data centers and co-location facilities to combine their physical building blocks of their hosted computing, their servers, CPUs, disks, load balancers, and so on. Now, this virtualization did provide a number of benefits. Your development teams can move faster, and you can turn capital expenses into operating expenses. But with the virtualization, you still needed to maintain the infrastructure. It was still a user-controlled, user-configured environment. And about 10 years ago, Google realized that its business couldn't move fast enough within the confines of the existing virtualization model. So Google pioneered a container-based architecture, a fully automated elastic third-wave cloud that consists of a combination of computing services and scalable data. Services automatically provision and configure the infrastructure used to run your applications. Today, Google Cloud Platform makes this third-wave cloud available to its Google Cloud customers. And as you can see here, Google Cloud does offer a wide range of computing options, spanning from the infrastructure as a service all the way into the automated elastic resources or serverless space. This particular example looks at the types of compute available. So as you can see in the infrastructure as a service, you can work with Google Cloud in the compute engine space. These are similar to your EC2 instances in AWS. You also have the option of going kind of halfway between IaaS and PaaS into the Kubernetes engine, which is considered a hybrid model. Moving further to the right, you can move all the way into the PaaS space with App Engine, which makes your applications extremely easy to deploy and scale. And then if you don't want to worry about deployment and scaling at all, you can move right into Cloud Functions, which is completely serverless, or your managed services, where all of the service management is handled for you by Google Cloud. So a wide range of possible approaches to developing your systems in Google Cloud. And the real strength, though, is in the platform as a service space, which we'll talk about in later slides. So another one of Google's key advantages over its cloud competitors is its incredible network, which includes hundreds of thousands of miles of dedicated fiber cable and eight undersea cables. So according to some publicly available estimates, Google's network carries as much as 40% of the world's internet traffic every day. Google's network is the largest network of its kind on Earth. They've invested billions of dollars over the years to build it, including almost 30 billion over the last 3 years alone. By comparison, that's more than Amazon's entire cash pile. And Google, with the third largest corporate cash pile of roughly $100 billion and annual corporate profits in the double-digit billions, they have the resources to continue to expand this network and the data centers in it and keep them unmatched in terms of quality of service. This peerless network is designed to give Google's cloud customers the highest possible throughput and lowest possible latencies for their applications and services. It interconnects at more than 90 internet exchanges and more than 100 points of presence worldwide. When an internet user sends traffic to a Google resource, Google responds to the user's request from the edge network location that will provide the lowest latency. Also, Google's edge caching CDN network keeps content close to end users to minimize their access latency. Now, looking at this map more from a data center perspective, here you have all of Google's regions and the zones within them mapped out. The teardrops are the regions, and the number inside is the number of zones. These are geographically isolated data centers within those regions, providing fault-tolerant, highly available, and critical failure isolated resources in those regions. So as you can see, Google has quite a big footprint, and they're expanding rapidly. So some of the regions here marked as future regions are already available, including the Montreal, Netherlands, and Finland regions. And Google's continuing to expand this out over the next few years. So this image shows Google's data center in Hamina, Finland. And with this slide, we're going to talk a bit about Google's commitment to environmental responsibility. So this facility here in Finland is one of the most advanced and efficient data centers in the Google fleet. Its cooling system, which uses seawater from the Bay of Finland, reduces energy use, and it's the first of its kind anywhere in the world. Google is one of the world's largest corporate purchasers of wind and solar energy. They've been 100% carbon neutral since 2007 and will shortly reach 100% renewable energy sources for all of its data centers. Now, this is important as the world is increasingly built on data center infrastructure, and current estimates are that roughly 2% of the world's electricity is consumed by such data centers, and that percentage is growing over time as more and more of the world becomes more and more data-centric in terms of operation. Additionally, Google's data centers are the first to achieve ISO 14001 certification, a standard that maps out a framework for improving resource efficiency and reducing waste. Another strength of Google Cloud is their customer-friendly pricing innovations. Google was the first major cloud provider to deliver per-second billing, and soon after, they forced all of their competitors to follow suit and also offer per-second billing. Such per-second billing is offered for users of Compute Engine, Kubernetes Engine, Cloud Data Proc, and App Engine, and Cloud Functions users actually pay to the nearest 100 milliseconds. So Google's constantly pushing the envelope in terms of pricing innovations. Google also offers, was also an innovator in terms of offering discounts for sustained use, where automatic discounts are provided for the longer that you use resources over any particular month. Additionally, Google provides you the ability to select custom virtual machine instance types to really tailor your workloads to your resource needs and ensure you're getting an optimized cost performance for your cloud workloads. Another strength of Google's platform is their commitment to open APIs and open source platforms. So Google gives customers the ability to run their applications that they've designed and developed in Google Cloud outside of Google Cloud if they believe that Google is no longer the best provider for their needs. This commitment includes their commitment to open APIs, such as those APIs used with Cloud Bigtable, the HBase API, also that you can use with HBase installations on premise, as well as you might be aware, Google's been a pioneer in big data with development of the MapReduce algorithm and the Hadoop infrastructure. And they offer a managed Hadoop platform called Cloud Data Proc that your workloads on Cloud Data Proc can be used with any Hadoop Spark platform, whether on-premise or in any of the major cloud providers. Additionally, Google's been a pioneer in terms of providing open source projects into the community that can be used across cloud providers and on-premise. Such popular projects as TensorFlow, which has become the dominant machine learning open source platform, Kubernetes, which has become the dominant container orchestration open source platform, and Forseti Security, which has become the dominant open source cloud security platform. As well as mentioned, Google's been pioneering open source projects all the way back to the Hadoop days when they open sourced Hadoop to the wider big data community. In addition to their open source commitments, they also make an effort to incorporate multi-vendor friendly technologies in their stack, including such tools as Google Stackdriver, which allows you to perform logging, monitoring, and other related application process management activities across cloud providers, including both Google Cloud and AWS, and Kubernetes Engine, which works with Kubernetes and allows you to deploy container-based applications and services across cloud providers, as all of the major cloud providers are either currently or in the near future plan to provide a Kubernetes-based service in their cloud offerings. And Google also has a strong commitment to security. And as you can see, Google manages this security at several levels. So right from the hardware level, both server boards and networking equipment in Google data centers are custom designed by Google. Google also includes custom chips, including a hardware security chip that is deployed on both the servers and the network infrastructure in their data centers. Additionally, Google servers use a variety of technologies to ensure that they are booting the correct software stack, such as cryptographic signatures over the BIOS, bootloader, kernel, and base operating system images. Google also designs and builds its own data centers, and they incorporate multiple layers of physical security protections. Access to these data centers is limited to only a very small fraction of Google employees, and Google additionally hosts some servers in third-party data centers where they ensure that Google-controlled physical security measures are added on top of the security layers provided by those data center operators. Their infrastructure provides cryptographic privacy and integrity for remote procedure calls on the network, as well as RPC calls between services. The infrastructure automatically encrypts all infrastructure RPC traffic which goes between data centers, as well as all data at rest in all the managed services, as well as all the block level persistent disk storage services available in Google Cloud. Google's central identity service, which usually manifests to end users as the Google login page, goes beyond simply asking for username and password. The service also intelligently challenges users for additional information based on risk factors, such as whether they have logged in from the same device or a similar location in the past. Users also have the option of employing second factors when signing in, including devices based on the Universal Second Factor Open Standard. Most applications at Google that access Google physical storage indirectly via storage services and encryption use Google-based encryption that does auto-rotation and management of all of the key infrastructure. You also are free to bring in and use your own key management with Google services if you so prefer. Additionally, Google provides a Google front end, which has designed built-in denial of service protection, mitigating all of the known layer 3 and layer 4 attacks, as well as tools to enable better protection for layer 7 attacks. And then Google maintains a high level of central control of their own systems, including central source control and two-party review of all code that they incorporate into their own services and infrastructure, as well as ensuring that all of their internal employees maintain user two-factor authentication whenever authenticating within Google Cloud's internal systems. So this slide just shows a sampling of a lot of the key features and functions available within Google Cloud. As you can see, we offer a comprehensive set of features and products across all of your core feature areas, including compute, storage, big data, and machine learning. Additionally, there are many ways to access the Google Cloud Platform. Of course, all of the Google Cloud Platform is accessed through RESTful or RPC-based APIs, but you do have the flexibility of using other interfaces that call these APIs on your behalf. Such interfaces include the Cloud Platform Console, which is a nice web user interface that you can access directly from your browser. For power users that prefer command line access, there is the Cloud Shell and Cloud SDK. The Cloud Shell allowing you to open up a shell interface directly from your browser, the Cloud SDK allowing you to install those tools on your local environment so that you can connect from a local terminal and perform command line operations against the Google Cloud. There's also mobile apps available for both iOS and Android, allowing you to access Google Cloud from your mobile devices, such as your phones or tablets. And for those who'd like to build their own services or provide programmatic access for automation purposes, you can directly interact with all of the Google Cloud Platform resources either via RESTful APIs or via modern HTTP version 2 RPC type API calls. So with that, we'll open it up to another quick poll question just to ask the user base, those who have used Google Cloud or are planning to use it, which interface types are you likely to, or how are you likely to want to interact with Google Cloud Platform in your own organization or for your own use?
Good. Yes, thank you for introducing that poll, Mark. So again, you can see the question there on how do you plan to use Google Cloud Platform. Again, if some of you are at the very initial phase of evaluating, you might have to think a little bit hypothetically as to how you envision your organization using it, but that's okay. So good. We're already about 50% of our audience has already chimed in, so we'll just give you folks another minute or so to complete that. Okay, so I think all of our votes are in, so thank you everybody for your participation. So Mark, what we're seeing is core infrastructure services definitely has taken the lead. 47% of respondents say that's how they plan to use Google Cloud Platform for core infrastructure services. Another 25% is to develop applications, 22% for big data or other data-driven solutions, and only 5% have said that they plan to use it for machine learning services. So again, thank you very much for that, everybody. So again, almost half plan on using it for core infrastructure services.
All right, thank you, Carl, and thanks everyone for answering that quick poll question. We'll continue on with some example use cases now. So first of all, we'll talk a bit about deploying REST APIs with the App Engine platform. So App Engine is a platform for building scalable web applications and mobile backends, very similar to Elastic Beanstalk in AWS. It allows you to concentrate on creating your applications by managing the application infrastructure for you. For example, App Engine manages the hardware and network infrastructure required to run your code and makes deployment very simple. And we'll see later on a demo of just how simple it is to deploy your code in App Engine. App Engine provides you with built-in services and APIs such as file storage, data services, caching, load balancing, auto-scaling, health checks, application logging, and a user authentication API. App Engine will auto-scale and load balance your application automatically in response to the amount of traffic it receives, so you only pay for the resources you use. Just upload your code and Google will manage your app's availability. There's no need to provision or maintain servers. App Engine Standard provides the best scaling performance available using Google's cutting-edge container technology, which is unmatched in the industry. It's the only platform in the world that can auto-scale your container instances in milliseconds. So you can go from 0 to hundreds of containers in fractions of a second. And App Engine works with all the popular development tools and IDEs such as Eclipse, IntelliJ, Maven, Git, Jenkins, PyCharm, Visual Studio Code, et cetera, et cetera. You can build your apps with the tools you love without changing your workflow. And this slide just shows you how easy it is to work with App Engine. And App Engine does provide a lot of dedicated services that make it extremely easy to leverage services such as caching, task queues, scheduled tasks, full text search, or logging. Additionally, it's a great tool for deploying microservices that allows you to deploy different isolated services, which can be micro in terms of providing an interface just for a very small scoped, very specific task. They also allow you to manage multiple versions of each of these microservices independently, and even to split traffic between those two as you roll them out to do canary testing or A/B testing or what have you. Provides development tools that allow you to develop and test locally, and then via the SDK with a simple one-line command, which we'll see later, you can deploy that code into the cloud and start immediately serving traffic from that code, where the Google Cloud will automatically auto-scale and load balance traffic to the instances running the containers of your code. So now moving on to another popular example use case is the tool called BigQuery. So that BigQuery is Google's data warehouse for performing OLAP workloads. Provides a near real-time interactive analysis over massive data sets into the petabytes plus. Allows you to do your queries using standard SQL 2011 SQL syntax, and it removes all of the overhead of any sort of cluster maintenance. So it allows you to perform SQL queries over massive data sets that are actually stored over distributed clusters, distributed data sets, but removes or makes that all transparent. So you simply worry about it getting your data into a BigQuery and then doing your big data analysis via full SQL queries over that big data in BigQuery. It provides such features such as flexible data ingestion, so you can load your data from cloud storage, any Google Cloud Managed Data Service, your on-premise DBs, or you can stream it into BigQuery at hundreds of thousands of rows per second to then later perform real-time analysis on that data. It gives you global availability, with the ability and the option to store BigQuery data in as many locations as you like, or as few, while continuing to benefit from the fully managed service. Additionally, you have full secure control over your data with full access control, controlling who has access to that data with fine-grained roles and access controls. You also have cost controls with cost control mechanisms enabling you to cap your daily costs at an amount that you choose, and various techniques to optimize your queries in terms of cost performance. Additionally, it's highly available with transparent data replication in multiple geographies if you so choose. You can also store it redundantly if you need to maintain strict data residency requirements. And it provides super fast and unmatched performance over huge data sets. And we'll see an example of that query that runs in seconds over hundreds of billions of rows of data. Additionally, you can integrate this with any other Google Cloud platform service very easily and seamlessly. So with that, we'll look at an example here. So this example talks about collecting data from a gaming service, and that's a popular big data use case these days. So popular mobile games, they can attract millions of players and generate terabytes of game-related data in short bursts of time. This places extraordinary pressure on the infrastructure powering these games and requires a scalable data analytics service to provide timely, actionable insights in a cost-effective way. To address these needs, a growing number of successful gaming companies use Google's web-scale analytics services to create personalized experiences for their players. They use telemetry and smart instrumentation to gain insight into how players engage with the game and to answer questions like, at what game level are players stuck? What virtual goods do they buy? And what's the best way to tailor the game to appeal to both casual and hardcore players? This reference architecture shown describes how you can collect, archive, and analyze vast amounts of gaming telemetry data using Google Cloud Platform's data analytics products. The architecture demonstrates two patterns for analyzing mobile game events. You can use batch processing. This pattern helps you process game logs and other large files in a fast, parallelized manner. For example, leading mobile gaming company DNA moved to BigQuery from Hadoop to get faster query responses for their log file analytics pipelines. And you can also use it with real-time stream processing. Using that pattern, you can, when you want to understand what's happening in the game in real time. With Cloud Pub Sub and Cloud Data Flow, providing a fully managed way to perform a number of data processing tasks like data cleansing and fraud detection in real time. Real-time processing is also a great way to continuously update dashboards of key game metrics, like how many active users are currently logged in or which in-game items are most popular right now. Some Cloud Data Flow features are especially useful in a mobile context since messages can be delayed from the source due to mobile internet connection issues or batteries running out. Cloud Data Flow has built-in session windowing functionality and triggers to aggregate events based on the actual time they occurred as opposed to the time they're processed, so that you can still group events together by user session even if there's a delay from the source, meaning that they arrive at the system at different times. But why choose between batch or real-time streaming? A key benefit of this sort of architecture is that you can write your data pipeline processing once and execute it in either batch or streaming mode, a key advantage of Cloud Data Flow. And Cloud Data Flow is actually the origin of a newly open source product called Apache Beam, which Google's recently open sourced. And it's the next stage in the evolution of a large-scale, massively parallel processing as a evolving member of the Apache Hadoop Spark family of big data. That's Apache Beam, and that's available for usage across multi-cloud or hybrid cloud or on-premise type configurations. Cloud Data Flow is effectively built on Apache Beam, providing you a managed service for running your Apache Beam workloads. And Apache Beam is built with both batch and streaming in mind, allowing you for full seamless support in your big data applications for both batch and streaming workloads. Continuing on to talk about how effective BigQuery is at crunching huge data sets, we have this slide to show an example. So on the right, you see a query there that's being executed against a huge data set. That data set is currently an open data set available when you're working with BigQuery. It's a data set that stores a record for each Wikipedia article written in each article across every language, all the articles written in Wikipedia. So this is a data set with over 100 billion rows. That is every article written in every different language that's been written in Wikipedia. And this query on the right-hand side is running against that huge data set of hundreds of billions of rows. It's running a regular expression to look for all titles in that data set that match the regular expression, essentially matching that the title of the Wikipedia article starts with a capital G, has some number of characters, an O in the middle, and then some number of characters. It's doing grouping across all matching articles by language and title, and it's finding across those groups the maximum number of views of those articles, and then it's doing an aggregate across all of that to find the largest or the amount of views aggregated across each language. And the incredible thing about this is it can run this query in 21 seconds. That is 4 terabytes of data being read, 100 billion regular expressions being run, 278 gigabytes of data being shuffled, and all just using, to optimize costs for this particular query, just using HDD hard disks. So it's not even using cutting edge storage. to optimize costs across this query. So it could even be perform this query faster if you wanted to, if you're willing to run it over SSD storage instead. By comparison, if you're running that serially, serial execution times there, you can see various tasks involved in this sort of query would run you into the days if you were executing it serially, just in terms of the huge amount of data being processed. So as you can see, a huge amount of parallel processing happening, all transparently behind the scenes, where you simply execute the SQL query as given on the right, and you get your response back in 21 seconds. So this kind of big data processing is unmatched in the industry. There's no other platform that would allow you to do this sort of query on this sort of data set. Another popular use case for Google Cloud is machine learning, of course. And the nice thing about using machine learning in Google Cloud is you can use it whatever your level of machine learning expertise. So if you have data scientists or machine learning engineers in your organization, you can use Google Cloud ML, which is effectively Google Cloud's managed TensorFlow service for you in Google Cloud. As you know, Google has provided the open source TensorFlow platform to the community to use either on-premise or in other cloud providers. But the Cloud ML is a great way to use a managed service for TensorFlow, as well as a few other popular open source tools, all in a managed environment within Google Cloud. But even if you don't have data scientists and machine learning engineers available in your organization, you can start using machine learning in your applications and services very easily using Google's prepackaged machine learning APIs that allow you to incorporate machine learning without having any expertise in machine learning at all. You just have to read and familiarize yourself with the APIs and the functionality that they provide, and you could start using those with as little as 6 lines of code. And they provide prepackaged machine learning APIs across such areas as speech processing, vision processing, translation processing, and natural language processing. We'll talk about some use cases of those in the next slide. So some common use cases for machine learning in application and services in various industries are in such areas as classification and regression, such business usages as customer churn analysis, product diagnostics, or forecasting. You also have recommendation, where you can use it for content personalization or product cross-sells or upsells. You can also use it in anomaly detection for such things as fraud detection, asset sensor diagnostics, or log metric anomalies. You can also use it for unstructured data, such as your image and video analytics. Examples are uploading images to retrieve any text in those images or labels, as well as any sort of inferment that can be taken from those images, such as context, locations, labels, and other details. Classic example is apps that use real-time roadside reading and translation, where you can hold your phone up to a road sign, and that is being displayed in a foreign language, and it'll do a real-time capture of the text in that roadside and translate it into English for you. So for example, if it was a Cyrillic road sign saying this way to Athens, it would translate that to English for you as a road sign to this way to Athens. Other examples are explicit content detection in both images and video, and text analytics for processing large amounts of text for purposes such as call center log analysis, language identification, topic classification, and sentiment analysis. So a lot of this can be used without being a machine learning expert or developing any of your own machine learning models. You can simply leverage the existing machine learning APIs that are constantly being expanded with more and more direct, easy-to-use application interfaces into their APIs. With that, we will do a quick demo now to show you how easy it is to deploy a REST API using the App Engine service. We'll be demonstrating deploying some simple little Node Express services in App Engine. With that, I'll show you my local environment here. I've got a setup here in Visual Studio Code on my local environment, where I've created a few little Node Express services. For those of you who don't have much familiarity with coding, these are extremely simple services. Essentially, they're Node Express services that receive HTTP requests and respond with simple responses. So I've got 4 different services, service 1, 2, 3, 4. You could think of these as separate microservices, and each one has a little bit of code that's just takes a request and responds with service X listening on port 8080. So service 1 would respond with hello from service 1. So I'll show you now how easy it is to deploy these services. I'll deploy service 3 here from my command line. As you can see, I have a command line terminal, a local terminal running on my local machine here. And with a simple command, gcloud app deploy, it will zip up the code in my local folder, send it to Google Cloud, build it into a container, and deploy it in Google Cloud's scalable infrastructure automatically, allowing me to start servicing requests from that. As you see, I just execute that command. It'll ask me if I want to continue. I'll say yes, and then it'll start deploying that. And with that, I'll actually show you, I've pre-deployed some of these services online. It typically takes about 5 to 10 minutes to deploy. And once you've deployed, you can see them online right now we're looking at the Google Cloud console, which is a browser-based user interface that lets you interact with all of your resources. As you can see, I've already deployed these 4 services here, and you can actually just browse to those services. So as soon as you deploy them, Google provides you with an HTTPS URL. It'll manage the SSL certificates for you and give you a URL. Of course, you don't have to use their pre-packaged URL. You can connect this to your own custom domain addresses with only a little bit more configuration. But if you want to start using it immediately, as soon as it deploys, it'll create these custom URLs for you, which essentially have the service name followed by the project.appspot.com. And as you can see, as I send requests to the service, it sends me hello from service 1 responses. And if I browse to service 2, as you can see, this microservice has its own URL, and it's sending its response, which is hello from service 2. Likewise, service 3 sends hello from service 3. And if I wanted to do an updated deployment from my app, I could simply, this one's still in progress, but if I wanted to change code, I could simply modify the code here and then run gcloud app deploy. And within 5 to 10 minutes, I could see the updated application and interact with that updated application or service directly from the console, or from directly browsing to that URL directly from my browser. Again, if I actually, to save myself browsing, I will show you how easy it is to interact. I could simply cut and paste that URL in a separate browser window, and it would make a request to that service. So I could do that from the command line with curl calls or with a tool like Postman. And again, this for more involved services, typically these RESTful APIs would be returning JSON, and they could be returning whatever sort of complex JSON that you'd like to use with your application.
So thank you, Mark, for that in-depth explanation of Google Cloud Platform and its different facets. Mark, one question that came in, it's from Adam, and he was just wondering how Google's network compares to the other ones that are out there, such as AWS, Azure. So I'm not sure at a high level.
Yeah, Google currently has the most dedicated fiber and the largest worldwide network. So in terms of network performance, you're going to get the best network performance of all of the large cloud providers in Google Cloud. So in terms of either network latency from users interacting with the cloud, or in terms of latencies between your resources within Google Cloud, they're going to be lower than with any of the other cloud providers. As well, Google will be able to provide much higher throughputs between resources across Google Cloud than any of the other cloud providers. Again, this comes down to Google's cutting-edge networking technology, which is unmatched by any of the other cloud providers, as well as just Google's extremely large network of dedicated fiber around the world that is also unmatched and is already carrying roughly 40% of the daily internet traffic around the world. So as you can imagine. And in addition to Google already having the largest and best performing network, there's no other cloud provider that can, the only other cloud provider that has the amount of cash available to invest is Microsoft. So Microsoft has slightly more cash than Google's parent Alphabet. However, Microsoft isn't investing the same amounts of their cash that Google is currently in their infrastructure development. So whereas Google has prioritized their cloud in terms of infrastructure investment, where they've invested $30 billion over the last 3 years, there's no other cloud provider that's currently prioritizing spending as much in their infrastructure. So in addition to Google already having a large lead in terms of the scale and capabilities of their network, they're also growing that network at a faster clip than anyone else, and they are in a much better position than anyone else, save perhaps Microsoft, in the future from investing that. Whereas Amazon has roughly 20-something billion in cash, Google has over 100 billion in cash that they can continue to invest. And whereas Amazon relies on their cloud services to provide a lot of their profits quarter to quarter, profits are not the Google Cloud is not a profit driver within Alphabet's organization, and where Alphabet is making double-digit billions per quarter or per year in profits, Amazon is only making single-digit billions in profits, and they need to rely on their cloud to provide that, whereas Google can rely on their other services to provide the majority of their profits. So Google currently leads the pack and will continue to do so for the foreseeable future.
How does Google provide support for users of Google Cloud Platform?
See, Google provides many different tiers of support plans. So depending on how your organization signs up with Google Cloud, you can sign up for different levels of support. That support can be a lower tier support, which offers the ability to open tickets within Google support and then receive different tiers of response. So you can have a 24/7 type support where you can submit a ticket and then get responses within an hour or so, or you can have lower tiers where, but my experience with the support that I've received while consulting with organizations working with Google Cloud is it's an excellent support. If you sign up for one of the higher tier support plans, you'll get responses typically within an hour, and Google will assign support engineers that will work with you to resolve your issues in a timely fashion. And typically, within a day, you'll have workable solutions to most issues that you encounter with Google Cloud Platform.
If you could comment on Google services for hybrid configurations and perhaps comparing that to AWS Store Gateway or Azure ASR.
Google provides many great features for hybrid cloud computing, many ways to integrate your data centers into Google Cloud. So there's several different ways to do this. From a networking perspective, Google provides great ways to integrate VPN connections into Google Cloud, as well as ways to direct connect your data centers into Google Cloud, either with direct peering relationships with Google Cloud or through third-party partners. They also offer great features. Specifically, API gateway functionality is provided by services such as Cloud Endpoints, which provides you an API gateway type wrapper functionality for your RESTful APIs. You can also use a more full-featured approach using services such as Apigee for that. And then, of course, Google provides great services such as Kubernetes Engine, which allows you to build federated clusters, both with hybrid cloud, where you have a federated cluster where you can run Kubernetes on-premise and federate that with Kubernetes clusters running in your Google Cloud, as well as federate that with Kubernetes running on other clouds such as Azure and AWS. And with these federated clusters, you have the effect of a logical cluster spanning both hybrid clouds and multi-clouds, where your workload can deploy pods across any of these clouds seamlessly without any concern for which cloud your workloads are running on. And the federated cluster can automatically redeploy workloads as services fail in different clouds between different zones and regions in those clouds or across clouds. For example, if one cloud was to have problems, you could redeploy your applications and services transparently to other clouds running in that federated cluster.
If Google has a data center in Canada, yes or no?
Yes, there is a recently opened Montreal region that is entirely within Canada that is centered in Montreal, but it has multiple zones. So I believe there's 3 or 4 zones that are spread around the greater Montreal area.
Okay, good, thank you. Further question on support. Paul was also wondering about documentation. Are there community forums that exist for Google Cloud Platform?
Yes. Google's online documentation is unmatched. So comparing myself, I'm mostly self-taught as far as Google Cloud, reading through the documentation available online. I tend to be self-taught in most subjects, but I found Google is unmatched in terms of back in the days when I was learning Android, I realized what a great commitment Google has to documentation, and Google Cloud is no exception. They have huge amounts of documentation available for any Google Cloud feature. All you need to do is type in any Google Cloud product in the search bar, and you'll be led to portals that have huge amounts of documentation available that you can peruse. In addition, any of the open source projects have a huge amount of documentation, like Kubernetes is a vibrant open source community. They have their own website, kubernetes.io or k8s.io, that has a huge amount of information available on Kubernetes. Any of the other open source platforms have huge open source communities with tons of documentation, but Google's own documentation is unmatched in any of their areas and includes such things as white papers talking about internal technical details and how they evolved their things like the container evolution, starting from such concepts as C groups, and Google's building out the next generation Docker engine, libcontainer, areas such as that. There's tons of white papers available online. So yeah, searching on any feature or function area in the search bar in a Chrome browser or in a Google search page, you'll find tons of documentation available on any of the feature areas in Google Cloud, and it's comprehensive across any of those, including, as mentioned, white papers talking about technical details of implementation. If you're interested, for example, on the Google Colossus file system, which is their next generation distributed file system that underpins most of their managed data services.
Okay, good. Well, thank you, everybody. Great questions that are coming in. We still have a few more questions. Here's an interesting one. Paul was wondering about the latest Gartner report that ranked AWS as first, Azure as second, Google in third place.
Of course, from a market share perspective, AWS still has a large market share advantage. They have the advantage of being an incumbent, having popularized cloud before the other providers came into the market. But a lot of that is more of a historical perspective, because in the earlier days, Google Cloud was more of a platform as a service only offering. So when Google first started their services, they had very little in the infrastructure as a service space. So their primary service offering was App Engine, which was a platform as a service. It was more recently that they started backfilling to add more infrastructure as a service offering. So from that perspective, you could say Google doesn't provide as much from an infrastructure as a service perspective as AWS, because Google started off as a more platform as a service offering. However, they have made a strong effort to backfill and to provide a lot of infrastructure as a service offering. So if you run infrastructure as a service these days, you'll find almost all the same features and functionality are available. There might be some gaps where AWS offers a bit more full-featured support, but Google is working tirelessly to try and close the gaps in any of the areas they exist. And in terms of performance, you will still see a huge advantage in Google Cloud, regardless of what you're running in. So as a simple use case, you can try the simple example of starting a virtual machine in Google Cloud versus starting a virtual machine in Azure or AWS. And whereas in Azure or AWS, even if you're starting a Linux virtual machine, it will typically take you more than a minute. On Google Cloud, it will typically take you around 30 seconds for your virtual machines to start up. So Google has a huge advantage in terms of their containerization technology that allows them to provision and start virtual machines much faster than any of the other cloud providers. So Google's been a pioneer in a lot of the infrastructure development. They've been slow to market and monetize that. AWS was a lot faster in terms of creating products to sell to other enterprise and users on these systems, but Google still has a huge advantage in terms of the underlying technology. So in terms of containerization, things like being able to auto-scale quickly, there's no other cloud provider that can auto-scale virtual machines on the order of a minute. There's no other cloud provider that can create and start your virtual machines on the order of 30 seconds. And there's no other cloud provider that can auto-scale your containers in milliseconds like App Engine standard. Google still has huge technology advantages over all of the other cloud providers, and they're still leveraging those to provide services that perform much better than the other cloud providers in those areas. But again, those strengths you're going to leverage more in the platform as a service and serverless space, where Google Cloud Platform as a Service and serverless, the performance gap is going to be much larger compared to Azure and AWS. In the infrastructure as a service side, although the performance is much higher in the Google Cloud, you might find there's a bit of a feature gap where they don't offer all of the comprehensive infrastructure as a service offerings because they've been playing catch up in that space and trying to backfill. But that is only a matter of time. As mentioned, Google has a lot more money to invest than AWS in all of these services. So I expect feature parity in the infrastructure as a service space within the next year or two as well. But again, infrastructure as a service is more of a legacy technology. Hypervisor-based virtualization is an obsolete technology. A lot of enterprises still run a lot of their workloads on that. But from a technologist perspective, it is an obsolete technology that provides performance that is vastly inferior to container-based technologies. And so because these are obsolete technologies, that's why Google's been a bit slower to backfill. But they realize there is still a large use case for a lot of customers that are using these obsolete technologies and systems and require cloud providers to support them. And so Google has made a great effort to provide support for those to try and help customers migrate to more cutting-edge container-based technologies. And so that's why you do see a little bit of a gap in the infrastructure as a service space in terms of feature parity.
So where the question then comes in, well, where do you go from here? Well, we can see before you here some of the recommended global knowledge courses. If you want to look at our complete curriculum, you go to our website, globalknowledge.com, and under brands, you can see Google Cloud. So for those of you who are still in that decision-making role, that phase, we recommend the Google Cloud Fundamentals course. It's a one-day overview of Google Cloud Platform, its products, its services. If you're in a design role, we have our Architecting with Google Cloud Platform Infrastructure. This is a 3-day hands-on course. Gets into the infrastructure and platform services that GCP provides. And if you're a developer, well, you can get into our 3-day course on developing Google Cloud Platform applications. So how to design, develop, deploy applications and seamlessly integrate that into Google Cloud Platform ecosystem. So again, thank you for this, folks. And in addition to our courses, if you go to our website, a lot of detail there, not just on what courses we offer, but learning paths, certification tracks, a really robust resource library that's full of recorded webinars, white papers, articles, and case studies. So really to demonstrate that our learning resources go much beyond just courses. So again, everybody, thank you very much for joining us. Thank you, Mark, for that presentation. And we look forward to seeing all of you very soon on an upcoming course or webinar. Have a good rest of the day, everybody.
Thanks, everyone.